Hello. In this video we're looking at MEI Further Pure 1, the May 2010 paper question 9, which is on matrices. It's a long question, so it's a good idea to read the whole thing through first. We are given two matrices and we're asked to describe fully the transformations P and Q. We're then given a triangle T, which is transformed by P and then by Q. So that's P and then Q. Our matrices are going to be multiplied in that order. The next part is indeed to find the single matrix that represents this composite transformation. For part 3, we're told that this composite transformation maps triangle T onto T dashed with vertices A dashed, B dashed and C dashed, so we're asked to find the new coordinates. The new triangle T dashed is reflected in the line y equals minus x to give a new triangle T double dashed, and we need to find the matrix that does that. And then we've got to get back from T double dashed onto the original matrix, and we've got to find the matrix representing that. So quite an intricate path. Okay, describing our transformations. So the matrix P maps 1, 0 onto the first column, 0, minus 1, and it maps 0, 1 onto the second column, 1, 0. So if we just do a little sketch of that, the point 1, 0 goes to 0, minus 1, and the point 0, 1 goes to 1, 0. So P is a rotation 90 degrees clockwise about the origin. Now let's look at the matrix Q. It maps 1, 0 onto the first column, 2, 0, and it maps 0, 1 onto the second column, 0, 1. So Q is just stretching in the x direction. Q is a stretch, scale factor 2, parallel to the x-axis. Okay, this triangle diagram is not actually relevant. We don't need to see a picture of that at all. All we need, in fact, are the coordinates. And we don't need them immediately. First of all, we're asked to find the single matrix that represents P followed by Q. That's the matrix QP. 2, 0, 0, 1. 0, minus 1, 1, 0. That's 0, 2, minus 1, 0. Then we're asked to find the new coordinates using this transformation. So the matrix we just worked out, which was 0, minus 1, 2, 0. And you can do this as a single calculation by putting all 3 points into one matrix, which saves a little bit of writing. And that gives us 0, 4, 2 on the top and minus 2, minus 1, minus 3 on the bottom. And our points therefore, the new A coordinate is 0, minus 2. The new B coordinate is 4, minus 1. And the new C coordinates are 2, minus 3. For part 4, we need to look at the matrix that represents reflection in the line y equals minus x. So as before, we consider the points 1, 0 and 0, 1, and we're reflecting in the line y equals minus x, which is this line here. So that's going to go to there, and that's going to go to there. and therefore 1, 0 maps to 0, minus 1, and 0, 1 maps to minus 1, 0, and combining these two gives us the matrix R equals 0, minus 1, minus 1, 0. So the triangle T dashed, I did P followed by Q and then R. So the full transformation from T to T double dashed is using RQP. Well, we already know QP, so R is 0, minus 1, minus 1, 0. QP we've already worked out is 0, minus 1, 2, 0. And that gives us 1, 0, 0, minus 2. And the inverse transformation to get us back from T double dashed back to T is going to be RQP inverse. So the inverse of the matrix we've just found, which is 1 over minus 2 take away 0. Swap the two terms in the leading diagonal and change the signs of the other two. So that's 1 over minus 2, minus 2, 0, 0, 1. And it's neatest if you minimise the number of minus signs. So I'm going to take the minus inside the matrix and get that as my final transformation, although having minus a half outside would be acceptable. Let's have a look at the mark scheme for this question. For part 1, there is a mark for 90 degrees clockwise and a mark for rotation about the origin. And for Q, there's a mark for stretch scale factor 2 and a mark for saying it's parallel to the x-axis. For part 2, there's a method mark for the correct order and an accuracy mark, correct answer only, for the matrix QP. For part 3, there is a method mark for pre-multiplying by whatever you got for QP. There is then an accuracy mark, just a single one, but it is follow through. But all three need to be correct. For part 4, there is a single mark for each column of the matrix R. And for part 5, there's a multiplication, a method mark for multiplication in the correct order, and an accuracy mark with follow through from previous work. And for finding the inverse, there is a method mark for attempting the inverse and an accuracy mark, correct answer only, for getting that matrix at the end. If you want to find videos of other questions on this unit or on other units, please visit the Further Mathematics Support Programme's website. Goodbye.